Okay, so as in the last video we have derived the formula for calculating the time period of a mass spring system or time period of motion under elastic restoring force or time period of Hooke's law. So we initially started with our general equation of the time period. Time period is equal to 2 pi over omega. We were also known that omega has nothing to do here, right? So we need to remove this omega, we need to remove this angular velocity. So how we must remove this omega? We said we must compare our both acceleration formulas. Initially we found the formula of acceleration of projection of a particle which is moving along uniform circular path, and we compared that acceleration formula with the acceleration formula of motion under elastic restoring force or Hooke's law or mass spring system. A is equal to minus x omega square is equal to minus k over mx. X cancelled with x, minus sign cancelled with minus sign, omega square is equal to k over m. We need to have the value of omega, not omega square. That's why squaring on both sides, omega is equal to under root k over m. Now as we found the formula of omega, or we found the value of omega, now we must substitute the value of omega in the general formula of time period, since we need to remove omega. So time period is equal to 2 pi over omega. Instead of omega, now we need to substitute omega's value. So t is equal to 2 pi over under root k over m. So we just simplify it and we got our final formula for finding the time period of a motion under elastic restoring force, and that is t is equal to 2 pi under root m over k, where k is the spring's constant, mass m is the mass of the body, and 2 pi is the numerical constant, right? So in today's video we are going to derive the formula for finding the frequency of the mass spring system or motion under elastic restoring force. Now see, initially we need to differentiate between two terms. What is the meaning of time period and what is the meaning of frequency? Now see, frequency, what is frequency actually? The number of cycles complete in 1 second is what we call the frequency. However, time required to complete one cycle is what we call the time period. So what is time period? What is time period? Time period is the time required to complete one cycle. What is time period? Let me write this here. Time required to complete one cycle. This is what we call the time period. However, what is frequency? What is frequency? Number of cycles complete in 1 second. Wait, let me highlight this first. Time required to complete one cycle is what we call the time period. Now today we are going to derive the formula for frequency. Deriving formula for finding frequency of mass spring system. Mass spring system. So what we are going to do today is we are going to derive the formula for finding the frequency of the mass spring system. Now see, initially we need to see what is the definition of frequency. What does mean by actually frequency? What is the meaning of frequency? It is number of cycles complete in 1 second. Complete in 1 second. What was time period? Time required to complete one cycle is what we call the time period. However, number of cycles complete in 1 second is what we call the frequency. So today we are going to derive the formula for finding the frequency of the mass spring system. How many cycles will it gonna complete in 1 second? This is what we call the frequency. So how many times this body will gonna complete its cycle, which means it will go to the mean position, it will go to the extreme position again, which means it will gonna touch its extreme position 2 times, right? So time, so how many cycles it will gonna complete in 1 second only? It can either complete its half cycle or it can complete its entire cycle. It depends on it. It depends on the speed of the mass spring system, right? So number of cycles completed in 1 second is what we call the frequency, or frequency is the reciprocal of time period. Frequency is the reciprocal of time period. Frequency is the reciprocal of time period, which means what? Which means f is equal to 1 over t. It is the reciprocal of time period, right? It is the reciprocal of time period. So f is equal to 1 over t. Now see, f is equal to 1 over, what is the formula for finding the time period of a simple spring mass spring system is 2 pi under root k over m. K over m or m over k? It's m over k, right? It's m over k. So 1 upon 2 pi into under root m over k. Now see, if we simplify it, what we're gonna get here would be 1 over 2 pi into k over m. So it will go up, right? So this is the final formula for finding the frequency of the mass spring system. How many cycles it will gonna complete in 1 second? This will gonna tell us frequency. What is the SI unit of frequency? So the SI unit of frequency is hertz. Symbolically Hz, which means hertz, right? So we have now derived the formula for finding the frequency of the mass spring system as well, or motion under elastic restoring force, which is f is equal to 1 over 2 pi under root k over m. This is how we find the frequency. In the last video we found time period, which is 2 pi under root m over k. Frequency is equal to 1 over 2 pi into under root k over m. So this was all for today. In the next video we're going to derive the formula for finding the velocity of the mass spring system or motion under elastic restoring force, or Hooke's law. So this was all for today.